Check it out over here. Q1 on B we are looking for, right? So
Yes.
when I am present on Q1, by reading the B input symbol, it is possible that I will be on same state, and at the same time as we have epsilon transition, it is possible that we can reach Q2 also. Understood, ma? Like this also you can do. Means without, I mean, if you want to save the amount of time in the sense, you can directly check from the transition diagram also. But the thing is, when you are doing the same in your exams, so you need to write all those steps. But when you are once you have done that, if you want to cross check whether whatever you did is correct or not, you can cross check through the diagram also. Okay. Then
Okay.
what about Q2 on CMA? I hope the same state, right?
Q1 on C, it is Q2, sir.
Yes, very good. Q1 on C will be Q2 itself. May I know how it is a Q1 on C on will be Q2?
Epsilon, because it is there is epsilons.
Very good, ma. Very good. Super. So on Q1, I don't have a direct transition on input symbol C, but still I am able to reach Q2. How? The reason for that is as there is an epsilon transition from Q1 to Q2, so I can say that. So there is a transition called a Q2. Very good, ma. That's it. Okay. Q2 on A.
There is no transitions.
Very good, because no, nothing. Q2 on B.
Q2 on B, there is no transitions.
Very good. Then Q2 on C, only one transition,
Q2.
which will be same. Okay. Now this is what we have got. Now once we have got this, okay. So now please check here. Now we got the same states Q0, Q1 and Q2, which are there in our NFA epsilon also. This is our NFA epsilon. In this NFA epsilon also we got Q0, Q1 and Q2, and in our NFA also. So this is our resultant NFA. Okay. So I'm telling to everyone, not only for her. Okay. So this is our resultant NFA. Okay. So please check out over here. So I already told you that the only change that we can find between the NFA epsilon and NFA will be, you will be getting an output without any epsilon transitions, and one more thing will be the final states are going to change. Okay. Then please observe. So these are the three states what we have in our NFA epsilon. The same states are again coming over here for NFA. Then whatever the initial state was there in our NFA epsilon, what is our initial state in our NFA epsilon? Q naught. The same state will be there in our NFA also. Okay, same state. Q naught will be the initial state. Now the only thing which we have to search for is the final state. Yes or no? Now when we want to design an NFA or DFA or NFA epsilon kind of thing, must and should there should be the final state. Okay. So how do you find the final state? This is very important. Please have a look at this. So now you have identified what are the states to be part of your NFA, and you have identified what are the transitions for your NFA, and you have identified what is the initial state also. Everything you have identified. The only thing which has been left is, which is nothing but the final states we have to identify. So how do you identify the final states? In the sense, the answer for that is, please have a look at this. Let me write. Please have a look at this. Now if, please have a look at this. If epsilon closure of, if epsilon closure of some state Q contains, please understand, please try to understand, if the epsilon closure of some state Q contains the final state, contains the final state, then Q also becomes, Q also becomes final state. Q also becomes final state. Otherwise final state itself will remain. Otherwise final state itself will remain. So what is the meaning of this? Let's check. Okay. So I think we already written the epsilon closure for Q0, Q1 and Q2. Have a look at this Q0, Q1 and Q2. Yes or no? Epsilon closure of Q0 we have written. Epsilon closure of Q1 we have written. Epsilon closure of Q2 also we have written. Now, in our NFA epsilon, please try to understand. In our NFA epsilon, what is the final state? The final state in our NFA epsilon is Q2. Let me write that one. So, final state in NFA epsilon. Let me copy from here. NFA epsilon is what is this final state? Q2. Okay, now we know that. Now what we have to do? Now we know the final state. What is the final state in NFA epsilon? Now we need to find out what is the final state in NFA only. Now how do we do that? Now for that what we have to do? We need to find out the epsilon closure of all the states. How many states we have? Q1, Q0, Q1, Q2. Now that is what I am doing. Now I am finding the epsilon closure of Q0, finding the epsilon closure of Q1 and finding the epsilon closure of Q2. Okay. Now just now I told you that if epsilon closure of some state, what is the state? Q0, for example, some state Q0. If the epsilon closure of Q0 consists of a final state, what is the final state? Q2. Now do we have a Q2 in the epsilon closure of Q0 or not? Please try to understand. If the epsilon closure of Q0 consists of the final state of NFA epsilon, then automatically we can say that this Q0 is also going to become Q0 will be the final state in NFA. Q0 will be the final state in NFA. Okay. Now let's go ahead. Second one. What is the second one? Epsilon closure of Q1. When I find the epsilon closure of Q1, I got an answer like a Q1 and a Q2. Now this set is consisting of Q2 or not? What is this Q2 is? Q2 is the final state in NFA epsilon. So as the epsilon closure of Q1 is consisting of the final state of NFA epsilon, now we say that Q1 is also the final state in NFA. Okay. Now the third one. What is the epsilon closure of Q2? Epsilon closure of Q2 will be the same state itself. As you know that Q2 will be the final state. So obviously Q2 also be the final state of NFA. So finally what we have identified is the final state of NFA will be the union of what? Union of Q0, Q1, Q2. In the sense, all these three states are going to become the final states. Okay. That is the reason why when I draw this, so here I am also going to denote something like star. So when I denote the star, in the sense, I already told you that, so all these states are going to become the final states. Okay, all these three states are going to become the final states. Okay, so if you want, I can show you the diagram also by drawing. Let me give some time, please wait a second so that I can open the software for you. Java, just give me 1 minute of time. Okay, let me share the screen. Now I am going to draw the output for you. Okay, so we already done the transitions part. completely. Now the thing which I am going to show you is, so this is Q naught, then Q1, Q2. So three states are there. Okay. So let me remove this. Okay. So that I can keep them aside. Okay. Now here we need to write the transitions. So Q naught on A, Q naught on A, it will be, so what is the answer for that? Q naught on A will be, let's go back to our table. Q naught on A will be Q naught, Q1 and Q2. So three states, it has transitions too. So Q naught on A, now I need to write the transitions. So Q naught on A will be Q naught, Q1 and then Q2 and then Q2. Oh, sorry. Wait a second. I need to remove this so that, okay. Let me drag over here so that it become very clear. So Q naught on A will be, okay, Q naught on A will be Q naught, Q1, Q2. Then the second one what we have is, just have a look at our table. Q1 on A will be 5, so we don't have any transition. Q1 on B will be Q1 and Q2. Q1 on B will be Q1 and Q2. So Q1 on B will be Q1 and then Q2 and then Q2. Okay. Then last one, Q2 on A will be 5, Q2 on B will be 5, Q2 on C will be Q2 itself. Go to the same state, Q2 on C. Okay. Now what we have to do now, we need to identify the initial state. What is the initial state here? We have find that Q naught is our initial state. Okay. So go back to our software. Oh, sorry. Okay. So let me select this. Let me make it like initial state. Now this is my initial state. Let me remove the del lambda transition. Okay. Then what are the final states? Just now I told you, as the epsilon closure of Q naught is consisting of the final state Q2. Now this state Q naught will become final state. So I am going to make it final. In the same manner, Q1 is, epsilon closure of Q1 consists of the final state Q2. So Q1 is also going to become final state. In the same manner, Q2 will be the final state. That's the reason why Q2 will be like this. Okay. Now please have a look at this diagram. Do you find, let me increase the font size. Now do you find anywhere any epsilon transition over here? But if you observe thoroughly, is it looking like a NFA or not? How could I say that whether it is an NFA or not? Because on Q naught, on A, by reading A, I am having three transitions possible. Okay. Now and it is possible only in the case of NFA, and at the same time on Q naught I don't have any transitions for B and C. Now this is how we are going to convert our NFA epsilon into NFA. Understood? So for that, what we have to do now, please try to understand. So these are the 4 steps which we have to remember. The first step is we need to identify the epsilon closure of all the states so which are remaining, which are available in our NFA epsilon. Then what we have to do now, for each and every state and as well as the input symbol combination, what we have to do, we need to identify the transitions. Okay. Just now I already told you that now we are doing the conversion of NFA epsilon to NFA. In the sense, the only thing which we are going to change over here is we are trying to find out an NFA, that is a non-deterministic finite automata, without any epsilon transitions. Now in our output, if you look into this output, we are able to find out a non-deterministic finite automata without any outputs. Okay, then once you have identified the transitions, now what you have to do now, using this delta dash table itself, now I am able to find out this NFA table. Now always please remember that just constructing the table itself is not enough. So what you have to do, you need to must and should draw this transition diagram. Okay, so please take down this transition diagram, everybody. So please take down this diagram. So this is going to be your final NFA, which is nothing but non-deterministic finite automata. Okay, now so just have a look at this. There is a small algorithm or theorem was there. Have a look at this. So equivalence of NFA epsilon and NFA or conversion from NFA epsilon to NFA. So what this theorem is saying that if L is the language accepted by NFA with epsilon, then there exists an NFA which accepts L without epsilon transitions. In the sense, for example, if I am having some language L which is accepted by NFA epsilon in the sense, then there exists a non-deterministic finite automata which accepts the same language L. So how? For example, let's observe. Now let's check whether this NFA epsilon, please check this NFA epsilon accepts A or not. Happily it will accept. How? So on Q naught, by reading A, I will be on same state A. But as I am having epsilon transition, I will reach Q1. On Q1, I will, by reading epsilon transition, I will reach Q2. Means finally, I am able to reach the final state. From this, I can say that A is accepted. Then B is accepted. C is also accepted. Then you can check over here. Does AB is accepted or not? Yes, happily AB will be accepted. Then one more thing, BC is accepted or not? Yes, happily BC is accepted. ABC is accepted or not? Very happily ABC is also accepted. Now just go back and check our NFA whether A is accepted or not. As Q0 itself is the final state, so A is accepted. B is accepted or not? As Q1 is the final state, B is also accepted. As Q2 is the final state, C is also accepted. Then one more thing which we are checking is AB, whether AB is accepted or not. On Q0, by reading A, I will go to Q1. On Q1, again when I read B, I will be on same state Q1. In the sense, I can say that AB is accepted. Then one more thing, BC, just check whether BC is accepted or not. I mean ABC is accepted or not. Just check it out. ABC is accepted or not. On A, I will go for Q1. On B, I will be on same state, or I can go for Q2, and then I can go for reaching the state C. So like this, please check. So whatever the language or whatever the strings so which was accepted by your NFA epsilon, the same strings are also accepted by your NFA. So that is the reason why we have a theorem like this. Please check it out. We have a theorem. What that theorem says that if I am having some language which is accepted by NFA epsilon in the sense, then the same language is also accepted by the NFA also. Now what is that language? Now from this I can tell you that there is a small relation. Please have a look at this. There is a small relation. What is that relation is? Please try to understand. If I am having an NFA epsilon, let me copy this epsilon. If I am having an NFA epsilon in the sense, now is it possible for me to convert this NFA epsilon into NFA or not? Just now we did, like we are converting the NFA epsilon into NFA. Yes. So if I have an NFA epsilon, then I can easily convert that NFA epsilon into NFA. Okay. If I am having an NFA in the sense, can I construct an NFA into a DFA or not? Can I construct an NFA into a DFA or not? Okay. So this is how we can say that So these three are the automatas are interrelated to each other. Now that is the reason why all these three and all three finite automatas, whether it is a non-deterministic finite automata with epsilon or without epsilon, or it is a deterministic finite automata, all these three languages accepts the same language, accepts the same language, which is the regular language. Okay, regular language. Okay, so that's the reason why there will be a questions will for you something like, so what is the automata which accepts the regular language, like that you may get a question. So the answer for that is the automata which accepts the regular language will be either a non-deterministic finite automata with epsilon or without epsilon, or it will be a deterministic finite automata. Okay, now the theorem for that is I have written in a very simple manner, very simple steps without much difficulty. What I did is, please observe. So this is our NFA epsilon and this is our NFA. Okay, I already told you when you go for NFA epsilon to NFA, whatever the states available in our NFA epsilon, the same states will be available in our NFA also. The input alphabet is also going to be same. But here you know that, so in the case of NFA epsilon, you will be having some additional thing which is nothing but epsilon. So this is going to be there in your NFA epsilon. And then we have a delta transition function, but we are going to call it like a delta dash in our NFA. And Q naught will be same in both the NFAs, but we have only one final state, but that final state will be changed in our NFA. Just now I told you, so what is that final state? It will be, we will be having all those states like a final state if and only if that epsilon closure of that state contains F. Otherwise, the same state will remain like a final state. Okay, so this is one small theorem. So if you are able to understand the conversion process, automatically you can easily understand this entire thing. Okay, now let's take one more example. Please take this example, and try to do so that I will discuss one more topic. So everybody take down this exercise. I will give you 1 minute of time. Please take down this exercise. And if you refer your textbook and if you look into internet also, there are plenty of NFA epsilon transition diagrams are available. So please try to convert those transition diagrams available in NFA epsilon into NFA. Okay. It's finished. Please respond either by raising your hand or unmuting yourself.
Sir.
Okay, thank you, ma. Now, I hope it is clear for you. Yes, is it clear for you? Now, are you able to convert the NFA epsilon into NFA? Please respond. Are you able to convert NFA epsilon into NFA? No answer so far. Okay, thank you. One answer I got, one response I got. Only one out of 64, only one. यार क्या हो रहा है यार, whether you are able to understand or not. Okay, okay, see, if this is it seems to be like you are not able to tolerate my pressure, so that's the reason why you are raising your hands. It seems to be like that. Okay. No problem. Now our next topic will be NFA epsilon to DFA. Okay, so thank you for all who have given the confirmation for me. Okay, so just now what we did is just now I have given some relation for you. I gave some relation for you. What is that relation? When you have NFA epsilon, it is possible that from NFA epsilon I can find out NFA, from NFA I can find out DFA also. Now it is also possible that from NFA, I don't know whether I am able to do it or not. Let me check. From NFA, okay, it is also possible for us. Oh, sorry. From NFA, it is possible for us to construct the DFA also. Okay. So once you have NFA epsilon with you, once you have a epsilon NFA epsilon with you, from that NFA epsilon, we can easily construct the DFA also. Okay. This thing also we can do. Like this also you can do. Like from NFA epsilon, find out NFA, from NFA to DFA. Already we have seen this conversion, NFA to DFA, how we can do. But along with this type of conversion, so it is also possible that once you have NFA epsilon, you can also convert that NFA epsilon into DFA. Okay. Now let's have a look at the steps. What are the steps we are going to follow? So first, what we have to do is we need to find the epsilon closure of all states of NFA epsilon. So first what we have to do, just like what we did for NFA epsilon to NFA conversion, first we need to find out the epsilon closure. Okay. Not for all the states, epsilon closure of, wait a second, not for all the states, epsilon closure of initial state of NFA epsilon. Initial state of NFA epsilon. Okay. Now, whatever the states we are getting as a result of epsilon closure of this NFA epsilon, now from there we need to start the transitions. Okay. So first what we do, we try to do this for this exercise. We try to convert this into NFA epsilon to DFA. Let's go to take this diagram. We'll do this. Okay. So we'll try to do this. So what is the, I think we also have the answer also. I think this one. Yes. Let's just copy. Okay. So okay. Now what is the initial state in our given diagram? In our given diagram, the initial state is Q0. So as the initial state is Q0, so I am going to highlight this one. Okay. Epsilon closure of Q0 will be Q0 and Q1. Okay. And in the same manner, epsilon closure of Q1 will be Q1 and epsilon closure of Q2 will be Q2, because from Q1 we don't have any epsilon transition. From Q2 also we don't have any epsilon transitions. Okay. Now what we have to do is now we need to define the transition function. So how do we define the transition function? The same, just like how we did here. Now we need to define the transition function. So just check over here. So how we are going to do is, just check. So delta dash of Q comma A, delta dash of Q comma A will be epsilon closure of, not epsilon closure, but it will be Q comma A. It will be Q comma A. So as per this, I hope I need to find out, sorry for the mistake, I need to find out not the initial state, epsilon closure of all the states of NFA. Okay. So now we have find out the epsilon closure of all the states of our NFA epsilon. Now what we need to do now? We need to find out the transitions for this. Okay. So how do you do that? So this is the formula what we have to follow. So delta dash of q comma a will be epsilon closure of delta of q comma a. Okay. So please have a look at this. So it will be something like, let me copy this, Control C. So epsilon closure of, so here what I do, it will be q naught comma 0. For example, q naught comma 0 will be epsilon closure of delta of q naught comma 0. Q naught comma 0. Now you know what is q naught to 0. Please have a look at this. What is q naught to 0? The q naught to 0 will be same state. Please try to understand. Q naught to 0 will be same state, which is nothing but q naught itself. Oh, sorry. Q naught to 0 will be same state, which is nothing but q naught. For this state q naught, now we need to find out the epsilon closure. So when I find the epsilon closure of q naught, the answer will be q naught comma q1. Q naught comma q1. Okay. Now this is what we got. Now for the same state, now what we have to do? We need to find out on input symbol 1. Q naught on 1. Q naught on 1. So epsilon closure of q naught on 1. So what is q naught on 1? On q naught, by reading input symbol 1, you go to state q2. You go to state q2. So epsilon closure of q2 will be what? Please have a look at this. What is the epsilon closure of q2? The state q2 will be same state q2. Okay. Now finally, please observe what actually we have got is, let me draw over here. Let me take a new finite automata. Parallelly we'll try to do. Okay. So initially we got q naught, and then on q naught on 0, please observe on q naught on 0, where we have gone? We have gone to a state called q01. Now what is the answer for this q01? Please remember the previous methods. Now I am going to call it like q01, and this q2 will no problem. So q naught on 0 will be q01. Q naught on 0. Okay. So let's take, this is q naught. Q naught on 0 will be q01. Okay, this will be q01. Clear label, sorry, change label, q01. This will be q01. Okay, so and then q naught on 1. What is the answer we got? q2. Q naught on 1, we got q2. So q naught on 1, let's better I write q2 over here. Okay, so q naught on 0, q naught on 0, we got q01. Q naught on 1, q naught on 1, we got q2. Okay, as this is our initial state. Oh, sorry, something wrong. Okay, so q naught will be our initial state. So just make it like a initial state. Now, as it is a DFA, please try to understand. As it is a DFA, on q naught I have transition specified for 0 and 1. Now these are the two new states which we got, Q01 and Q2. For Q01, again what I have to do, I need to specify transitions on 0 and 1. And for Q2 also, again I need to specify transitions for 0 and 1. Let's go ahead and do it for Q01. Okay, so let's take, what is this? This entire thing. Okay, so Control C, Control V. So this is going to be Q01, Q01 on 0. Okay, this will be the delta closure, epsilon closure of delta union, and here this will be delta of Q0 to 0 and delta of Q0 to 1. Now please try to understand why I am taking union, because Q01 in the sense it is the combination of two states, union of two states, and these two states union on input symbol 0. That is what I am doing. So Q0 on 0 union Q0 on 1. Then epsilon closure of Q0 will be what? Epsilon closure of Q0 will be, Q0 on 0 will be, I mean delta of Q0 on 0 will be Q0 itself, and Q0 on 1 will be Q2. Q0 on 1 will be Q2. Okay. Now when I find the union of epsilon closure of Q0 union Q2, what is Q0? So Q0 Q1, and what is the epsilon closure of Q2, which is Q2. So when I do the union of that, now you will get Q0 Q1 and Q2. So a new state which we are going to get will be Q012. Okay, so this is the one more state which we are going to get. Then again, so for this Q01 on 1, Q01 on 1. So now we need to do the changes. Q01 on 1, and oh sorry, have I identified a mistake? Q0 on 0, okay, and here it should be Q1 on 1, not Q0 on 1, because it's a combination of 0 1, right? So Q0 on 0, okay, Q1 on 0, Q1 on 0. So what is Q1 on 0? Please have a look at this. Q1 on 0, I don't have any transition. So as I don't have any transition in the sense, obviously it will be 5. It will be 5. There is a small mistake committed. I'm sorry about that. So it will be 5. So where is this? This is 5. Okay. And epsilon closure of Q0 will be same. Q0 Q1. So no new state, Q0 Q1. Okay. Then Q01 on 1 will be Q01 and Q11. Q11. Now what is a Q0 on 1? Q0 on 1 will be Q2. It will be Q2. Okay. And then what about Q1 on 1? On Q1, by reading input symbol 1, you don't have any transition. So it will be 5. So it will be 5. So what is epsilon closure of Q2 now? The epsilon closure of Q2 will be the same state. The epsilon closure of Q2 will be the same state. Okay. So finally what we got? Q01 on 0 will be Q01 only. Q01 on 1 will be Q2. So go for doing that. So Q01 on 1, Q01 on 1, sorry, let me remove this. Okay. So Q01 on 1 will be same state, and Q01, I mean, sorry, I think Q01 on 0. Okay, Q01 on 0 will be same state and Q01 on 1 will be Q2. Okay, wait a second. So Q01 on 0 will be same state and Q01 on 1 will be Q2. Okay, now we have set the transitions for Q01, which is the new state. Okay, now please check our diagram. Please check our diagram. We have Q0, we have specified transition on 0 and 1, and then we got a new state. For that new state also we have specified transitions for 0 and 1. Now from this Q01, did we got any new states? No. Now the only state which is remaining for us is Q2. Now for this Q2 we need to define the transitions. Okay, so I am going to take this one, Control C. Okay, so Control C. So Q2 on 0 will be epsilon closure of Q2 on 0. What is Q2 on 0? Do we have any transitions? Q2 on 0? No. On Q2 we have transition only for 1. We don't have any transition for 0. So it will be 5. It will be 5. So let me copy this 5. Okay, somewhere over here. 5. Copy. So which is nothing but 5. So finally the answer which we are going to will be F5, which is nothing but a dead state. Okay, then the next thing what we have to do is now Q2 on 1 we need to define. So Q2 on 1 will be epsilon closure of delta of Q2 to 1. What is Q2 to 1? Please have a look at this. Q2 to 1. Q2 to 1 will be Q1, Q2, which is nothing but two states. We are getting Q1, Q2. So here it will be Q1 union or Q1 comma Q2. Epsilon closure of Q1 comma Q2. Now what we have to do now, we need to find out the union of epsilon closure of Q1 and epsilon closure of Q2. So already we find the epsilon closure of Q1 comma Q2. What is epsilon closure of Q1? It will be Q1, Q2 will be Q2. So finally the answer what we are going to get will be Q1, Q2. Now which is a new state? Q12, which is a new state. Okay, on 0 we go to dead state, on 1 we go to new state. Okay, so Q2 on 0, please wait a second. Q2 on 0 we go to a dead state, and you can call it like a Q3 state, and on 1 we go to a new state called, let me rename this. Let me rename this. I call it like a, this is the problem with this software. I am going to rename this with Q12 state. Q12. Okay, so Q12, I mean Q2 on 0 will be Q3, and Q2 on 1 will be Q12. Okay, and here once you are on dead state, whether you read 0 or 1, you will be on the same state. You will be on the same state. Now we define transitions for Q0, Q01, Q2 and Q3, which is a dead state. Let me rename this. I can call it like a D also. Let me change the label, D state, dead state. Okay. Now what I have to do now, I need to define transitions for this new state, Q12. Just 1 minute time I am going to take. 1 minute only. Q12. Okay, Control C, sorry, is it there? Control Z, Control C. Now we need to define transitions for this. Okay, Q12 on 0. So here Q1 on 0 and then Q2 on 0. So what is Q1 on 0? Nothing. Q2 on 0 is also nothing. 5. Both are 5. So here, so this entire thing will result in 5 itself. So epsilon closure of 5 will be 5 itself, which is nothing but we can call it like a dead state. We can call it like a dead state. Okay, so this will be a 5 state. So control C, control V, and then Q12 on 1. Q12 on 1, which is nothing but epsilon closure of Q1 on 1 and epsilon closure of Q2 on 1. Now please have a look at this. What is Q1 on 1 and Q2 on 1? Q1 on 1, 5. On Q1 we don't have any transitions, but Q2 on 1 it will be same state, Q1 and Q2. So Q1 on 1 will be 5. Sorry, Q1 on 1 will be 5 union. Now Q2 on 1 will be Q1 comma Q2. So Q1 comma Q2. So finally what we are getting over here, when we do the epsilon closure of Q1 Q2, what is the answer for this? The epsilon closure of Q1 Q2 will be same state. Epsilon closure of Q1 Q2 will be same state, which is nothing but Q1 Q2 itself. Now we call this like Q12. Q12.
Benar itu, kira-kira Yurat, Siddharth,
Hello, Om, can you please mute yourself? Hello? R2, can you please mute yourself? Okay, so now please specify the transitions for Q12 on 0 will be 5. Q12, this is Q12 on 0. Q12 on 0 will be 5, which is a dead state. And Q12 on 1 will be the same state. Q12 will be at the same state. Okay, now everything we have defined. Now please observe, finally we have reached to the state where we have defined transitions for each and everything. We have defined transitions for, wait a second, let me check that diagram. Sorry, we have defined transitions for each and every one. Okay, see here we have defined transitions for Q0, Q01, Q2, Q12, Q3, which is a dead state, and for each and every transition. Now please observe, this is going to be my DFA. Okay, now once I have identified the DFA, the next thing which I need to do is I need to find out the final state. Now this is very simple. Finding out the final state is very simple. So how do you identify the final state means? Now have a look at this. So what is the final state in our NFA Epsilon? Please have a look at this. What is the final state in our NFA Epsilon? Q2 is the, Q1 is the final state. Yes or no? Please have a look at this. What is the final state in our NFA Epsilon? Q1. Now whatever the state where you find Q1, make it like a final state. Okay, so this is our diagram. So this is Q0 state and this is the Q01 state. Now we have a Q1 or not? Yes. Now what we have to do is, now please give me 1 second. Now what we have to do is, we need to make it like a final state. Why I'm making it like a final state? The reason for that is, So as this state is consisting of Q1, which is nothing but the final state in my NFA, hence this Q01 is also going to become like a final state. And what about this Q12? In this Q12 also we have a Q1 or not? Yes, that is the reason why. So this is also going to become the final state. Okay, then in Q2 no, and Q3 no. Okay, so please take down this. This is going to be your final diagram where we are converted our given NFA epsilon into NFA. Okay, so please take down the diagram. Wait a second. Please take down. This is going to be your final DFA. Okay, now how could I am saying this is a DFA? Because on each and every state we have transition specified for only one transition is specified for one input symbol at a time. Okay, not more than one. Okay, so please take down this. So this is going to be your final DFA. Okay, so let me copy this. Let me check whether this thing will be copied or not. Or I do one thing, I will take the screenshot of this and I will try to paste it in my word screen so that I can share it with you. Because with this today's class, we have finished that finite automatas part. In tomorrow's class, we will discuss about the finite automata with the output. Now it's up to you, like you have to practice more on doing the conversion from NFA epsilon to NFA and NFA epsilon to DFA. Okay, so if you have any doubts, please feel free to ask any doubts either in WhatsApp group or you have my personal number also. So please put your doubts through that. Okay, so any queries? Okay, so thank you very much for joining the session. So have a nice day.